Hi, my name is Nandikishore. I am from CSIT branch. Today my topic is elemental and compound of semiconductors. To understand the semiconductor materials that are suitable for electronic devices, to study the properties of the material for electronic devices, semiconductor devices are fabricated using specific material has the desired physical properties: metals, insulators, semiconductors, superconductors. Metals. Materials with zero band gap are metals. A metal has a partial filled conduction band, so there is no energy gap between filled and unfilled region. A significant number of electrons can be existed by heat into empty energy levels and move easily throughout the metals, allowing the materials to conduct electricity. Insulators. Materials with an energy gap larger than 3 electron volts. An insulator possesses a considerable energy gap between the valence band and the conduction band. It is difficult to exit electrons from the valency band to the conduction band. As a result, an insulator does not conduct electricity. Semiconductor. Special class of materials having conductivity between that of a good conductor and that of an insulator. A material with electrical resistivity lying in the region of range of 10 power of minus 2 to 10 power of minus 10 power of 9 ohms per centimeter. Material whose energy gap for electronic excitations lies between 0 and about 4 electron volts. A small number of electrons from the valency band promoted to the conduction band by an energy gap of a thermal energy. Semiconductor. Classification of semiconductor materials: elemental semiconductor, compound semiconductor, narrow band gap semiconductor, wide band gap semiconductor, oxide semiconductor, magnetic semiconductor, organic semiconductor, low dimensional semiconductor. Semiconductor. Elemental semiconductor: silicon, germanium. These are the important group of fourth elemental group of semiconductors. All of them have diamond crystal structures. Boron, it belongs to group 3. It has rubidium crystal structure. Phosphorus, it belongs to group 5. Sulfur, selenium, beryllium, this belongs to the group 6. Elemental semiconductor. Currently, silicon is the most important semiconductor material used in electronic devices. Advantages of silicon over other semiconductors are a relative case of passivating the surface by oxidizing in a controlled manner, forming a layer of stable negative oxide that substantially reduce the surface of recombination velocity. Its harness that large bare phase to be handled safely without damaging it. It is thermally stable up to 1100 degrees Celsius that allows high temperature process like diffusion oxidation. It is relatively low cost due to the establishment of this process. Elemental semiconductor. Limitations of silicon: its energy band gap is 1.12 electron volts. It is a direct semiconductor that limits the applications in optoelectronics. It has a relatively low carrier mobility as compared to other semiconductors such as gallium. Compound of semiconductors. They are usually formed from third group to fifth group, second group to fourth group, and fourth group to sixth group. Third group to fifth group semiconductors are GASN, GAP, GAN, ALAS, and etc. In general, these crystallized materials, compound semiconductors GAS in AS, have direct energy band gaps and high carrier mobilities. Common applications of these semiconductors used to design a variety of optoelectronic devices for detection and generation of electromagnetic radiation in high speed of electronic device. The energy band gap of these compounds are useful for optoelectronic applications. The energy band gap range from 0.17 electron volt for to 3.44 electron volt for gallium semiconductor compound semiconductors. For second and fourth group compound semiconductor such as zinc and compounds with oxygen O S Se, these cover a wide range of electronic and optical properties due to the wide variations in their energy band gaps. These are typical N-type or chrome, except zinc terbium, which is P-type. All the second and sixth group compound semiconductors have direct energy band gaps. Semiconductor compound semiconductors. For fourth and sixth compound semiconductor, PBS, PBSC, and PBTE, characterized by narrow energy gaps, have carrier mobilities and high dielectric constants. The unique feature of the direct energy gap in these compounds is that its energy band gap increases with increasing temperature, which means the energy gap has a positive temperature coefficient. Main applications of these compounds are in light emitting devices and detector in the infrared spectral region. Thank you for giving this opportunity.